Hello everyone. Today we're going to be looking at how to read and how to use algebra tiles. We're going to be doing this over the course of 3 slides, so watch out for that. And we're also going to be going over an extension that I'm expecting you guys to have done the next time that I see you. So make sure that you get on that after watching this video. So first, let's jump into how to read these algebra tiles. So when we look at these algebra tiles, what we're going to be naming them as is we're going to be naming them as the area that they represent. So this first algebra tile here will have an area of 1 times 1, which will give us 1. Right? That's just a base times height. This next triangle, next rectangle will have a 1 times x, which will give us x, again, base times height for a rectangle. So this rectangle will be represented by x. This square up here will be 1, and this square down here, again, it's a base times height, so we're going to have an x squared. So this square will be represented by x squared. Now, for this next tile here, or this next slide here, we're going to be applying our algebra tiles to solve this expression here. And we're going to be equating this to something on the right. So when we do this, we're going to be taking this term here in x. So we're just going to take this x, and I'm going to write it down here. Look here, this is my algebra tile that will represent x. I just turned it sideways, and you'll see why in a bit. And then I'm going to write 2 1s, because I don't have a tile for 2. I'm just going to make 2 1s. So this is my 1, and this is my 1. Now I'm going to multiply this with this expression on the right of it. So let's do the x first. The x, I'm going to put it right here. This is my x, and the last 1. So it's only just 1. So it's just 1, 1. So there we go. Now, when we work these out, see how typically we would multiply these two expressions. We're going to do that here. Let's take this side length of x and this side length of x. And when we multiply them out, we're going to be getting an x by x, right? Which will give us our x squared tile. Here we're going to have a side length of 1 times the side length of x, which means we're going to be having a side length of x times side length of 1, which will give us our x tile. Again, this will be a side length of x here times the side length of 1. So again, this is going to be our x tile as well. Down here, we're going to be multiplying that side length of x times side length of 1, which will give us a side length of x, or side length of 1 with a side length of x all around this rectangle here. Now here we start having something a little different, but it's still the same thing. A side length of 1 times side length of 1. So we're having a 1 square right here, a 1 tile. And the last one here, again, is a side length of 1 times a side length of 1. So we have a 1 square right there. So now what we're going to be doing is we're equating it. So as you can see here, we have only 1x squared. So it's going to be equal to an x squared. We have 3 x's. So we have plus 3x because they're all positive. And we have a 1 and a 1. So it's going to be plus 1 here. Plus 2, right? Because we're gonna add up our 1s. Now for this one here, I want you guys to try it out. I want you guys to use the algebra tiles, maybe look back to what you wrote down for number 2, and use that as a reference to solve this problem here. Once you guys finish, come back to me, and we'll see if you did it correctly. Right. So if you guys did it correctly, we're going to be starting off by drawing our algebra tiles. And we see an X in that first position, so we're going to make an X here. And then we're going to have 3 ones, all right? So 3 ones, so that's 1, that's 2, and that's 3. 3 ones. And then we're going to have an X, okay, so only one X. Put that right there. And we're going to have 2 ones, so 2 ones, okay, 2 ones right there, and another one right there. So now that we're going to multiply them out, right, if you were looking at these side lengths, right, we're going to have a side length of x times side length of x, which is going to give us our x squared tile right here. We're going to have a side length of x times the side length of 1, which is going to give us our x tile. And we're going to have our side length of x times the side length of 1. It's going to give us another x tile here. We're just going to keep doing this, right? You can see, you can kind of, you look towards the left, you look above, and you see what kind of tile you should be drawing. Here we have an x, side length of 1, an x, and then the last one down here, for the x's at least, we're going to have an x and a 1. And now we just need to do all of our 1s. So we're going to have 1s here, another 1 here, right? Because we're looking towards these side lengths that would be up here and up here to the side. And these are all going to turn into 1s. So now, as you can see, hopefully, we're going to have 6 1 tiles. So we have 6 1 tiles right here. So now what this equation is going to be equated to is we're going to have 1x squared. So 1x squared tile right there. We have 1, 2, 3, 4, 5 x's. So plus 5x. And then plus 1, 2, 3, 4, 5, 6 ones. So that's just 6. Right? So hopefully you guys got the same answer as me. If you didn't, go back, look at what you guys did, and see where you went wrong. Maybe you drew the wrong tile somewhere. Maybe you just didn't add up your tiles correctly. Just look back at your work carefully and see how you might have messed up. Here we have our extension. So this one here, as you can see, it's got something that we haven't really dealt with so far. And I want you guys to try to figure out how to work around it, how to work with it to make your other tiles work. If you guys can figure it out, then that's great. If you can't, we'll get into it. But I strongly encourage you guys to really try it, and I'm sure you guys can come up with an answer. And we'll get into it tomorrow on how to really solve this problem. All right. Have a good day, guys.